Hello everyone. So in this video, I would like to share, about how to differentiate between these two formula to calculate the E naught cell. As I mentioned previously, the E naught cell is a standard cell potential. Standard means the reaction takes place at 25 temperature. The pressure is 1 atm, and the concentration for all the electrolyte involved is 1.0 molar. If the concentration change, the value that measured from the voltmeter is no longer E naught cell, it will become the E cell. Alright, so what is the difference between these two formula? Right, so let's look at the differences. Alright. So let's say I give you one example. The E naught cell for aluminium 3 plus and aluminium, which is negative 1.66 volt, and the E naught cell for nickel 2 plus become nickel is negative 0.23 volt. So if we have the information in this kind of information, first we need to check, right? So this is 3 become 0, which means it represents the reduction. And this is 2 become 0, which means it represents a reduction process. So how to decide which one will become an anode and which one will become a cathode? So this is how I usually use to identify. So let's say the middle is 0.0 volt. So when you go upward, it will become more positive. So between these two, this is positive, right? Aluminium, right? Become positive 1.66. Aluminium is positive. And this one is negative 0.23 volt. So we can conclude that aluminium will become a cathode while nickel will become an anode. Right. So we know that reduction occurs at cathode and oxidation occurs at okay. If I choose the first formula to determine the E naught cell, so the formula will be like this: E naught cell equal to E naught cathode minus E naught anode. My cathode is aluminium, which is 1.66, so I just put positive 1.66 volt, minus my anode is the value negative 0.23 volt. So my E naught cell 1.66 plus 0.23 become positive 1.89 volt. So this is the voltmeter reading for the reaction between aluminium and nickel, where nickel become our anode and is our cathode, right? So don't forget to put a positive sign in front because it shows that it is a spontaneous reaction. Right. If I decide to use the second formula, what will happen? So if we use the second formula, so it is, where should I put? E naught, so to use this one. Okay, E naught equal to E naught reduction plus E naught oxidation. So if you look at here, the E cell value given, E naught cell value given, represent the reduction process. Because 2 become 0, 3 become 0. Okay, so for E naught reduction, you can straight away take the value because cathode reduction and this equation also So you can put the value positive 1.66 volt plus. Okay, because this value represent when nickel undergoes reduction. When it undergoes oxidation, you have to switch the value, meaning that negative 0.23 when it's become a cathode, when it become an anode, or when the value become positive 0.23, which means you have to switch the value. Okay, so from 0.23 become positive 0.23 volt. So this is the difference. That's why we put plus sign here. And finally, you still can get the same answer, which is positive 1.89 volt. I don't recommend you to use this formula because I'm worried if you forgot to switch the value, because the E naught cell value given represent from standard reduction potential. When it undergoes oxidation, you must switch the value from positive become negative or negative become positive. That's why I recommend you to use the first one. But if you're familiar with this one, you can proceed with this. Cuma, make sure you write a correct formula. Either cathode minus anode. If you choose reduction, reduction plus oxidation. Okay, so I hope that this video will help you to differentiate between these two formulas. Actually, both will give the same answer, but the method used in the calculation is a bit different. Okay, because of this. Only for the oxidation, you have to switch the value. If you choose this one, you don't have to switch the value. Okay,